Welcome to our HB Tuners live training session part 3 with our Pontiac Firebird. In this video, we're going to be taking a look at getting our engine fired up and tuning our mass airflow style operation. In addition to this, we're going to take a look at tuning our idle control as well. There's going to be a lot of things to talk about and look at between our VCM scanner and our VCM editor. So let's jump into our live training session so we can get started. Welcome back to our live training session here with our Pontiac Firebird. In our last video, we learned how to go into our VCM scanner, add all of our custom channels that we want to log, go in and build histogram tables, and using chart versus time layouts, we've learned how to build all that. If we actually jump here to our VCM scanner, this is now all set up to do our fuel, spark timing, and idle control calibration process. So that's what we're going to be starting to handle in this video. We're going to be taking a look at doing our mass airflow tuning specifically, and then the next video we're going to be doing our speed density VE style tuning. Again, it's really simple based on how we've set everything up here. I'll be going through all of that process, but we're going to be dealing with two major things in this video that's going to affect whether you're in math mode or speed density VE mode. Now that's going to be our idle control. We need to get that sorted out, as well as our injector information, all of our injector data. So let's talk about our idle control first, and then we'll talk about our injector data and why both of these are going to have to get sorted out. It's going to be extremely important. First, the idle control. We're going to find that we have an aftermarket cam installed into the engine. Anytime we put a larger camshaft in an LS engine, we're generally going to lose torque at idle. That's going to cause us to have a lower idle or stalling if we don't go in and deal with the idle control tables. So we're going to have to go in and calibrate. If we jump into our actual file here, jumping into engine, let's jump into idle and into airflow. We're going to definitely have to go into the base running airflow and reestablish this table. Now, because this is a idle control motor equipped setup here, so if you're dealing with a truck application or Corvette, they're generally going to be drive-by-wire. This is not. This is a cable-driven throttle body with the idle control motor. So drive-by-wire has the ECM controlling the throttle plate movement to open the throttle to regulate a certain amount of airflow coming into the engine as part of the idle control naturally. And then we use spark timing to get our idle torque sorted out so that it idles right at our target. Now with the idle control, with an actual idle control motor on a cable-driven throttle body, it's going to be moving our stepper motor open or closed to allow the airflow to come in, similar to the idea of working with a drive-by-wire throttle body where it moves the actual throttle plate movement to let the airflow in. We're going to be doing it through that auxiliary controlled airflow leak, which is our idle control motor, which is a stepper motor. What we're going to find is that the ECM is going to be translating how much airflow we want to have coming in to stepper movement, or each amount of steps. More it opens in steps from 0 to 310 steps. So the more it opens, the more airflow it's going to be letting in, which we're going to be essentially commanding here in our table, in our base running airflow table. Now, the nice thing about working with a cable-driven throttle body is that we can go in and not actually have to necessarily touch our base running airflow and increase our values to allow more airflow into the engine. We can go and move our throttle plate open more, which is the same kind of concept or idea as the drive-by-wire control, electric throttle control, moving the throttle plate open itself, allowing the airflow to come into the engine. It doesn't matter if it comes in through the throttle plate or if it comes in through the base running airflow table through the actual programming of the stepper motor. Now, generally, it's more desirable on a cable-driven throttle body to open that throttle plate up more to allow more airflow in that way, rather than taxing the idle control motor, the stepper position. Now, there's some rules with this that we're going to be talking about once we get the engine to fire off. And namely, when we have a warm engine, so the engine's all the way up to operating temperature, we want to see that our idle steps on a warm idle is anywhere between 30 to 40 steps. That's going to allow the idle control routine to have enough control through the rest of our tables here, through the throttle follower, the throttle cracker, any of our adaptive idle airflow tables, working with our cooling airflow offsets. Any of these tables is going to allow us to add the additional airflow and essentially translate that to a stepper position, or the movement, the opening and closing of the idle control. That'll allow it to function the way that GM has intended. So there's going to be some rules with that. Once we get it up and running and once we start to go in and sort that out, I'll be demonstrating what we need to do. Now, more than likely, we're going to have to open the throttle plate screw. I haven't touched it yet. It's still in the stock default location, but we are going to most likely have to do that because I don't think this is going to just start up and run on its own. We haven't touched any of our idle control parameters here. So we've kept right now under the base set point, we've kept our stock RPM targets of 800 RPM. This should be able to idle between 8 to 900. We might have to bump this up. And then in our base running airflow, these are all the stock values. We have not changed those. So again, the ways that we can get our idle torque back is going to be our spark timing and or our airflow. Airflow will naturally, the more air we let in, the more fuel we put in, the more torque the engine's going to make. And that's going to be one way to go about it. The other way to go about it is our spark. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.